Hi, Lebo, can you hear me?
Yes, Cornelius, we are actually now live.
Okay, thank you.
Let me start up.
Okay.
Oh, shit, I did wrong. Okay, can we, okay, either we need to put our hands up or something because I can't see. There we go.
Oh, he wants
There
a
we go.
crowd.
Okay, there we go. Thank you so much. Perfect. Okay, super. Welcome, everyone. The scene is rather hot. Anyway, welcome for everybody who missed the traffic. I believe there's some people still stuck on William Nickel. Is that normal for Joburg to have traffic lights on the flight?
Yes.
Really? Okay, so I am making an official decision that next year we're doing this in Cape Town. So if you come to know ahead of time, you guys are all welcome in Cape Town and we'll do Table Mountain afterwards. So welcome everyone, welcome to the last day. Today is going to be a really, really exciting day. Just a couple of things I want to mention. Yesterday was fantastic. What we forgot to do was there's a couple of prizes. I know JetBrain's got about 3 licenses that they're giving away. So whoever needs a JetBrain license, I don't know how we're going to vet this, but Twitter's going to come into play. So our handle is Java Africa. Sorry, that's our handle is Java Africa, and hashtag is what's the hashtag?
ICJ22.
ICJ22. Thank you. So there's 3 licenses. ICJ22 hashtag. So we're going to be grading that. So if you want a JetBrain license, by all means, we're going to be getting it at the end of the day for that. And also Microsoft is giving a bag and some GitHub cups away. I think that's also going to be drawn at the end of the day. But welcome everyone. Without any further ado, I'm going to introduce a gentleman that's pretty much been instrumental in getting everything together. I think we've been doing this since 2015.
Yes.
Since
December
2015.
2015.
And believe you me, there was a little bit more people than what we see now. So COVID definitely had an impact. So without, can we give him a huge round of applause for Corneil, please?
Thanks very much, Theo. Good morning, Intellect and everybody else. I see coffee has found you well. I need to press a button here, eh? Can you hear me better? Great. Okay. Well, welcome everybody. And thanks for joining us. Sweet streams are made of this. I saw recently on Twitter at some conferences and stuff, people are doing musical numbers. This is not going to happen. Even though I'm surrounded by family members with musical talent, it skipped me. And when I got to high school, the music teacher said, no, you should not sing in public, so don't worry about that. But my son came up with this catchy title, and I decided to retain it. So what are we going to talk about? So I'm going to talk about Spring Cloud Dataflop, and we'll be touching on Spring Batch and Spring Task and Spring Cloud Functions and Spring Cloud Stream applications. And I'm going to interview that rare thing in the open source world, a user. You just usually see them in your GitHub issues. And then we're going to have a Q&A. So what is Spring Cloud Dataflop? So you might have heard of the concept of enterprise integration, application integration, and you might have heard of enterprise integration patterns. There's actually a website by that name, done by a gentleman by the name of Gregor Hoppe. And even though it might seem old, it is actually still relevant. And the nice thing is you can implement those patterns with Spring Cloud Dataflop. So what does it do? In a nutshell, it is a mechanism to orchestrate microservice-based applications that are either batch jobs or tasks or stream apps. And those are then deployed into a runtime environment that can be Cloud Foundry or the commercial version, Tango Application Service, into Kubernetes. And if you want to give yourself sleepless nights, you can run it as a set of processes in a VM. But I would not advise that. And it supports observability via Micrometer, which is a project that you can see as like SLF4j, but for metrics. And that means you can get these metrics out to Prometheus or Wavefront or InfluxDB and have a Grafana dashboard or whatever to visualize. So if you have a organizational monitoring system, you get the seamless integration. So what does it look like? So what I want to start with is to show you what you as the developer will experience. So if you want to create a stream flow, we have a DSL that you can use that looks like this. So if you've used the command line, which if you haven't, you better start because you're wasting a lot of time clicking around. This might be familiar. So if you've got pipe symbols and redirect symbols, that should be familiar. So what's happening here? Well, we're saying read a file, send it to a splitter, and then do a transform. So let's assume the file is CSV, and the splitter says split it on line feeds, and the CSV to JSON transform, you use it to create a JSON representation of that row, and you send it to an input stream. So that colon input stream results in a topic on a bus. And then you can say, well, I also have an HTTP endpoint that I send to the input stream. And then I say, well, take the input stream and send it to a filter, and the filter decides what continues. And then I can send it to an aggregator. So the aggregator is like a group by, but with a time window. So you can set a time window that will aggregate stuff and then dump it out. So if you need to collect data and make decisions on a time window, not just an individual data point, the aggregator is useful for that. And then we send it to an output stream. And now we take the output stream and we send it to JDBC, or we transform it to JSON that we want to send to a WebSocket. So what does that look like in a different representation? So this is a bit busy, but let's give you a closer view. The UI will produce this representation that you see based on that DSL that you type. And it'll tell you, no, I don't know this application, because each of those blocks is a registered application. So you register applications. These that I'm showing you are some of the prepackaged applications that you can configure and use, but you can create your own. So you get this representation when you're busy with that DSL. When you then say create a stream, in this case, because I have the those topics, which we call tabs, the tab results in the stream being separated into separate streams that look like this. So it'll actually create a stream that goes from a source, HTTP, into a tab, and it'll create another one that goes from the file source to the splitter, to the transform, and to the stream. And they both result in messages ending up in the topic. And then this is the one that does the interesting work. It just goes from the one topic to another topic. And it does the filter and the aggregation. And then there's another stream that does the output to JDBC, or the output stream to the transform to the WebSocket. So these are all separate streams that you can then deploy and manage as you need. We can also orchestrate tasks. Now, batch job is a special kind of task that uses Spring Batch to do its work. So with Spring Batch, you can take a file and you can process batches of the file. And you basically configure all the steps, and it will then batch based on your configuration. So you can tune it to get the right size to get optimal performance. And because if you have ever had something that reads a line of a CSV and then updates the database and then reads a line of a CSV and updates the database, you'll realize this is damn slow. But if you take that same work and you take the JDBC side and you batch it so that you have 100 or 1,000 at a time, then you'll see it goes a lot quicker because the database is good at that. But if you do 1,000,000, then you can kill the database because the overhead of the transaction can be too big. So that's why you can tune this. So when you're orchestrating this, you now have multiple tasks that you can then say, I want them in sequence, but these can run in parallel, and you can define a task workflow, if you may, that in this sample, we do a billing run, and then we generate billing messages, and we generate the billing report. The billing messages goes to the people who have to pay the bills, and the billing report goes to the business that says, well, this is what we're expecting. So these two can run in parallel because they all use the same shared data. But that orchestration doesn't move data around. It just orchestrates the execution of the applications that are either a task application or a batch application. So how did we build this? Well, if you know the Spring ecosystem, you'll think of it as dependencies that I add to a project. But Spring Cloud Dataflow is a product. It's not just a project. So that puts a different weight on the project. You'll hear me referring to us. That's because I'm a member of the team building Spring Cloud Dataflow and taking it forward. So everything is a Spring Boot application, which makes things very easy. We use Spring Security to configure our security to the application. We use Spring Data for persistence. We use Spring Batch and Spring Integration in the implementation of these prepackaged tasks and stream applications. And you, as the user, will use those components to build your task or batch application or your stream applications. Under the Spring Cloud banner, there are lots of projects that we leverage. Some of the most important ones are the message bus. So Spring AMQP is actually an implementation that usually leverages RabbitMQ, because AMQP is a messaging protocol that RabbitMQ implements. Or we use Spring Kafka. And but there are other buses that are also supported. So, but in that case, you will have to follow some instructions to build and generate that version of the application. Because basically, we take the Spring Cloud function, which is essentially, you can view it as just a module that has a piece of code that's either a function that gets something and gives something, or it's a producer that produces messages, or it's a consumer that consumes messages. We wrap the producer and we create a sink, a source, and we wrap the consumer and we create a sink, and we wrap the function and we create a processor. So that wrapping process is typically just code that gets generated with the dependencies for the relevant binder, which is either Rabbit or Kafka, or whatever else you want to use. And that thing gets generated and built. And then we package that in a container when we deploy to Kubernetes. If you deploy to Cloud Foundry, you give it the Maven coordinates of the application that you want to deploy. So this is what the architecture looks like. So you either have a UI or the REST client or the shell that interacts with the Dataflow server. You can give that REST client or the UI or the shell that DSL, and then properties that configure that DSL further. Because JDBC endpoint implies the JDBC URL and credentials to talk to a database. So you have a way to define those properties. Skipper is used to deploy the application into Cloud Foundry or Kubernetes. And what you'll see those little icons, that's the Spring Boot icon. So those things are Spring Boot apps. There's the message bus that implements the topics. And that's as simple as it is. And now the DSL determines what the runtime configuration is going to look like. Here's an example of a dashboard for observability for streams. So you can see for each of the streams, there's the stream apps, there's some metrics that tells you about the throughput and the latency. Those are things you want to watch. If the latency goes down and the throughput goes down, then you know something bad is happening. And you can put that on a dashboard and watch the health of your system. If you're looking at tasks, you typically want to find out how long did they take to run, how many have run. And we had a customer who discovered the other day that a T2 Nano database does not like 1.2 million entries in the task history. So take note, the database cannot be that small. And then here's a list of prepackaged stream applications. Now, this is very noisy. I'm not going to jump in there. I'm going to show you a smaller list. Now, I've already spoken about the aggregator and the filter and HTTP and all of those. Interesting one is the Dataflop launcher. My ear is obviously not big enough to hold the mic. So the task launcher allows you to launch a task based on a message. So obviously you don't want to do that hundreds of times per second because you are going to have some interesting side effects. But it's a very useful thing that you can launch a task based on what's happened in a stream. And your application can also feature there. So you've got this whole ecosystem and you build your application. Now comes the more interesting part for me, is that I get to introduce you to a user. So please welcome Vincent Chegwidden. Some of you may know him. And we discovered that we have a customer just down the road from me who is using Spring Cloud Dataflop because they posed a question on deploying to Kubernetes, and obviously, as part of the team, I saw the request came through. I said, no, we must make contact and see if we can help them. So part of their request is on our roadmap. But I'm going to ask Vincent to come and stand here. And Vincent's going to tell us a bit about their journey leading him up to standing here. So, Vincent, I'm going to hand it the clicker to you. And please tell us, how did you end up here?
Sure thing. Everyone can hear me fine? All good. Morning, everyone. Thanks for the intro, Corneil. Yeah, so it's been an interesting journey to get here, but I mean, it all started with the process that we were running, right? So a little bit of history before we get into the juicy details. So we had this process. It was getting data in from different sources, the main ones being a file and a web service, right? We pull all of this data, we go dump it in a database, and there it sits. It's not really the main purpose of it, but that's where it starts. Second thing it does is there's a batch process. So we've got all of this data sitting in this DB, and then on a schedule, we go and we fetch a lot of it. When we've fetched all of that data, we do some processing on it. And then the final step, once we're done with that, we route it back to our database. So I'm pretty sure everyone has seen things like this implemented where they work. The thing about this is there's some problems, right? And the main one is, what do you do, or what happens when there's some bad data in there? Now, keep in mind, this is an old system. It wasn't written with some of the more modern technologies that's out there. So if you had some bad records in here, what would happen is this processing job would fail. And then because the processing job fails, either because it can't read a row or because of some completely unexpected result, then you can't write to your DB. Once that happens, then you have to do the entire thing all over again, and it's just extremely inefficient and very frustrating. Also, finding those bad records is like finding a needle in a haystack. So yeah, we knew we had to do something about that. The other issue that we had was more a thing about technology. So because it was older tech, hard to find dinosaurs these days. They're not all out there anymore. But yeah, we had to find people to work on this stuff. And then, you know, you get the guys who don't want to touch it. And it's easy to make fun of them. You know, ooh, it's scary. But when you get a language that does stuff like this, it's also not hard to blame them.
So, Vincent, how did you end up with Spring Cloud Dataflop?
So we basically took our process and we had to redesign it. We started off by saying, okay, we've got this big chunk of data. And how do you get through it? How do you eat an elephant? The answer is one bite at a time. So break the process down into smaller steps. The other things we were looking at, we wanted to enable more real-time processing of this data. So not that batch-based, wait for something to happen, something happens kind of flow. And we wanted to improve the feedback loop. So if there's bad data, something goes wrong, you react to it immediately. Okay, the next thing, we wanted to use Java because we've got a lot of Java devs. They know the tech. And the last thing we looked at was something that follows more of a functional programming style. It's not like pure functions, but these are all of the things that we considered in our design, right? And eventually that led us to stream processing. And the tool that we chose to do the orchestration for this was Dataflop.
Okay, so then I suppose that you use Spring Cloud Stream applications to do a lot of the work.
Well, yeah, in fact, we do. Most of our apps are streaming apps. So you can see in this picture, every little Spring Boot icon is a microservice, if you will, and it's a streaming app. So what we do is we take our big file, take a single record out of that, and that can get processed through each application. We still got our web service that gets data in, but I mean, that was a lot easier to bring into the system because it's a single record already. So then data flows through there. Eventually, you can bring this stuff together if you want to, or process them individually. The nice thing here as well is if you've got that piece of bad data, it's a single record, it goes through until it fails, and then you can send it to some kind of custom error handler, where either you manually intervene or there's some automated process that tries to fix it and put it back. Great thing is these applications are all idempotent. So that bad piece of data goes through, you fix whatever caused the failure, you can always put it back through again.
So do you still do any batch type work?
Yeah, in fact, this file that we process, there's a Spring batch job that does that. So that batch job takes the file, splits it into individual records, and puts those records onto a Kafka topic.
Okay. So do you have any processors that have side effects?
Yeah, I mean, the thing is at some point you have to write to the DB. So you're doing all of this processing, that information needs to find a place to rest where it's useful to other people. So we've got these applications that are both processors and data producers or sinks. We bundle them together in a single app, but you could also split them into multiples if you wanted to. But yeah, the important thing for us is these processes are built to be idempotent, meaning that you can do the same thing over and over without causing issues.
So what is the developer experience like when they have to build the components and application that make up your solution?
Well, for us, it's pretty awesome. Everything is a Spring Boot app. Our developers love that. They love working with the tech because you can test stuff locally, run the application straight from your IDE. Also easy to do unit and integration testing using JUnit and Spring Boot test. So that makes it really easy for us. What we've done is we've built some custom templates as well. So if you start up a new project, you just start from the template. And you don't have to set everything up from scratch. We added in some dependency management bombs, so you don't have to worry about versions. The developers basically just pull in which dependencies they need and they go on with their life. Helps us to keep stuff a little bit uniform as well. And then I guess the last 2 points, applications are small, they're easy to understand. You look at something, it does one thing, you know what it's going to do. And then everything is bundled in containers. I mean, everybody loves containers, right?
So how do you deploy and manage this solution?
So what we're doing is we're deploying to Kubernetes, of course, because everyone's doing that. But seriously, we are deploying to Kubernetes because that was the thing that made the most sense to us. We're using our Helm chart that was built by Bitnami. Our message broker is Apache Kafka, so that's how we connect our streaming apps together. And then I guess one of the issues that we ran into while we were doing this, we use a non-open source DB. So we had to go and do some modifications to Dataflow itself. But because it's open source, it was pretty easy to do that. And then everything is on JDK 17 because we didn't want to start off on the back foot. No point in starting off and then you have to upgrade already. Okay, for our streaming and our batch apps, so these are the custom applications that we've written ourselves. We followed a GitOps approach. All of that stream definition, the applications themselves, so the versions, the Maven coordinates, everything is in Git. And then we interact with the REST API that Corneil mentioned to go and deploy this stuff. So there's no one going and logging into a production UI and saying, oh, put this application in there. Okay, and then the final piece of the puzzle that makes everything come together is monitoring. You want to be able to see what's happening when you deploy this stuff. So we push out application metrics so that we can see what our app's health is, see that it's in a good state. We monitor all of the topics for any lag. That means you can see if you start to get any issues, if anything is falling behind on processing. And then all of the logs that we have are exported so that if the pod dies, afterwards we can go and see what happened there. In terms of scaling, we actually haven't had to do a lot here. So first thing we started off with was making sure that the JVM is happy. Give it enough memory, make sure that you set important parameters like which garbage collector to use. And from that point on, you can scale if you need to. But for us, honestly, we've been running single instances of all the apps without any problems. Doesn't mean that we can't scale if we need to. Obviously, we can. And the way that we can go about that is there's some feedback that you can get back from something like Prometheus, and that can tell your apps to scale if you see that there's a lot of lag on one of the topics. So yeah, that's basically how we got to this point and what brought me here.
Thank you very much, Vincent. So we are now open for questions. If you have any questions, you are welcome to fire away. Yes.
Yeah, for a question for Vincent for the use case. How much data do you actually typically handle?
So at the moment, we started off small. We didn't want to test this out on brand new tech. We're doing about 100,000 records a day, either coming in via that file or the service. But we've got plans to ramp that up significantly. We've already tested out the throughput of these things, so you have to make sure that your apps can handle it. And what we've seen in terms of throughput, we can handle a lot more.
Yes, there's one back there.
With your stream processes, I don't know if you've decided, because you can set up a listener concurrency in your sort of stream, like I don't know, with JMS you can set a stream or you a concurrency for your listeners. Have you found that using, especially with like microservices, smaller pods, more small pods with a lower listener concurrency, or do you have quite a large listener concurrency with low listener concurrency with civil?
Well, I can jump in here. Usually what you do with this type of thing is you actually set your concurrency to 1. Because even though it's IO bound, you know you're running fine. And if you then see you have a problem, you can decide which way you scale, because it obviously depends on whether the ordering is important. Because if the ordering is important, then going beyond 1 is a problem. And with Kafka, you've got partitioning, which basically gives you a dedicated slot for your listeners. And the stream apps will then decide whether it runs all the stuff in 1 or it spreads the load over multiple instances when you do that type of work. So you've got knobs to turn, but it's very much more deterministic because you typically stick to 1 and you're very explicit if you want to partition up. Anybody else? Okay, maybe I can offer some stuff on what's coming down the line. So you may be aware that Spring Boot version 3 is going to be released before the end of the year. For us, the first step is we want to make sure that you can use Boot3 to create stream apps and task and batch apps, and that we can launch them correctly. And it brings some nice observability improvements. So it's probably going to be easier for you to take your apps and move them up to Boot3 and add some more observability, because then you will have metrics and spans, and you can log your correlation IDs, and you can get a lot of visibility across things. And we will then look at moving Dataflow itself up, and then making sure that even the new Boot3 Dataflow still orchestrates older apps properly. Which also brings us to another interesting topic, is that you can do polyglot apps. So if you're using Kubernetes, or even in Cloud Foundry, where you can deploy a container, you can create a stream app with Python and use that. There's people who use some of their ML flows and feed that into Dataflow to enrich data and stuff, and then send it back out, or they do their ML in a step. So that's something that we want to improve, so that the experience is as good and simple as it is with Spring Boot-based apps. And then we're also looking at technologies like WebAssembly, because it's great for doing work at the edge. I imagine you've got something that can orchestrate WebAssembly apps, but it's running inside of a CDN or IoT or wherever, and that data also ends up in your bus, and you can still orchestrate those apps and update them and change their configuration if you need to, all from one environment. So you don't have a separate place where you need to manage those things like you do at the moment. Because if you want to do that now, all the system would know is, oh, there's an MQTT source coming from somewhere, but that somewhere is invisible to the rest of the system. And these are some of the things we're looking at. And then the one thing that they asked for is they want to be able to easily deploy to multiple environments. So if you have 2 Kubernetes clusters, at the moment, that's 2 Dataflow installations. Now, if you configure all your topic names by hand, and you have a Kafka installation spanning those clusters, then 2 Dataflow installations running on those clusters that look the same will operate on both without a problem. So the solution will happily run across both and scale well. But you don't want to have to manage each of them separately. You want to be able to talk to one Dataflow and say, deploy this to that cluster and deploy the same thing to that cluster. And maybe there's some differences between what you want to configure within those. So that's something that we're looking at adding to make it easier for you to operate across multiple environments. Anybody else with questions? Well, if you're shy, you can come and look me up when I'm topping up my caffeine levels. And thank you for joining us. And if you want to take it for a spin, there are some resources. We have a little, we call a microsite dedicated to Dataflow. There's a repo, but that's not the only one. You'll see that there's lots of moving parts. If you want a copy of the slides, it's the bottom link. And we also have a link to all the prepackaged applications. So take it for a spin. Shout at me if something doesn't work. We're trying to make it better. And thank you for your time.
Brilliant.